All right, this video is for students who need help with solutions to linear equations on Study Island. This is our first problem, but before we get into it, let's talk a little bit about equations and what type of solutions you might get for an equation. And what does it mean to get a solution to an equation? If you have a real simple equation, something like, we'll say x plus 5 equals 8. That's a real simple equation. What it's asking you is, what does x have to be for this to be true? The solution to the equation is what number you could put in for x, and that this would be a true statement. So could I put in 4 for x and for this to be true? No, because if I put in 4 for x, 4 plus 5 is not equal to 8. So 4 is not the solution. Obviously, the solution here is 3, because 3 plus 5 equals 8. Some kids get lost and they forget that very basic thing of what it means to solve an equation. And it means that you are trying to figure out what the variable is that makes this statement true. If you keep that in the back of your head, the rest of this will go pretty easy. Now, if I say that x is 3, I'm saying that that is the solution. There's no other solution to this problem. X equals 3 is the only one. No other number could be plugged in for x to make this true. I can't plug in 2 or 4 or 3.1 or -5 or -3 or anything. The only number that works is 3. So there was one solution to this problem, and the solution was 3. That's it. That is one type of situation that you're going to run into, an equation with one solution. Now, in the type of equations that you're being asked to work with right now, you're not going to get more than one solution unless it's infinite solutions. So what does that mean? What do you get with infinite solutions? Well, let's do a new equation. Let's say I have 2x plus 4 equals 2x plus 1 plus 3. What is that equation? Now, you might have noticed right away, this says 2x plus 4, and this says 2x plus 1 plus 3. Well, if I add 1 and add 3, that's the same as adding 4, right? So yeah, I could rewrite this equation as 2x plus 4 equals 2x plus 4. And now they say the exact same thing. That's kind of weird. What is the solution to this equation? Again, the solution is what number can we plug in that makes this true? So just ask yourself, could I plug in 0? And this would still be true. Well, let's see. 2 times 0 is 0. 0 plus 4 is 4. So if I plug in 0, the left side is 4. The right side, 2 times 0 is 0. 0 plus 4 is 4. So the right side would be 4. So the two sides would be equal if I plugged in 0 for x. So 0 is a solution because 2 times 0 plus 4 is equal to 2 times 0 plus 4. Okay, that worked. So I just write x is 0 and move on? No, because I could plug in other stuff. I could plug in 1. 2 times 1 is 2. 2 plus 4 is 6. Over here, 2 times 1 is 2. 2 plus 4 is 6. No matter what you plug in for x, this 2x is going to be worth the same as this 2x. And since you're adding 4, you're adding the same amount to both of them, you're not going to get any differences in the left expression and the right expression. They're going to come out to be the exact same thing no matter what you plug in for x. You can plug in 0, 1, 10, 100, -10, -30, pi, any number you can think of, any number that exists. If it's real, you can plug it in here and it'll work. So if I was going to ask you, what's the solution? You'd have to tell me all the numbers are solutions. Anything I plug in. So if I say, well, how many things can I plug in? There's no end to the number of things I can plug in. I can plug in any number, and numbers keep going on forever. So it keeps going on to infinity. So how many solutions are there? There are infinite solutions to this problem. Infinite solutions. There are infinitely many solutions because I can plug in any number into this equation for x and it would still be true. So that is one of the situations you might run into. You might run into a problem where the x is on one side of the equation, are the exact same number of x's on the other side of the equation, and they cancel each other out. And when that happens, if the stuff that's left is still the same, then you're going to have infinite solutions to that equation because the x's canceled each other out and the stuff that was there was still equal to each other. So it didn't matter what you plugged in for x, it would cancel itself out anyway, and the remaining stuff would still be equal. So no matter what you plugged in for x, it would work. But that's not the only thing that could happen. There's one more weird thing that could happen. Let's say you had, 3x plus 5 equals 3x plus 7. Well, you might realize that on the left side there's 3 x's, and on the right side there's 3 x's. So kind of like our similar problem above it, they're just going to cancel each other out. No matter what this is worth, this is going to be worth the same amount. Whatever I plug in for x, I got to plug in for this x also. So 3 times that number is going to be 3 times that number on both sides. This amount and this amount are the exact same. But what's left? One of them's plus 5, and one of them says plus 7. How could I add 5 to some amount and it be the same as if I had added 7 to that same amount? Is that possible? And the answer is no. This right side is going to be 2 more than the left side, no matter what I plug in for x. So if you're asked to find out what value for x makes this statement true, it's impossible. There's nothing you could plug in for x that would make these two the same, because the x's would cancel each other out, and what you have left on both sides doesn't match up. On the previous problem, we had the same amount on both sides, so there was infinite solutions. No matter what, those two sides were going to stay equal. But on this one, no matter what, the two sides are not going to be equal. So there are no solutions to this problem. It's impossible to do. So you can say there are not any solutions. This is an impossible equation to solve. So these are the 3 scenarios that you're going to deal with these types of equations. You're either going to get one solution, infinite solutions, or no solutions at all. How do you tell what? Well, one solution is when the x's don't cancel each other out. I only had an x on the left side here, so it didn't cancel out with an x on the right side. That meant I was going to get one solution. But in both of these problems, there was the same number of x's on the left side of the equation as there was on the right side. When that happens, they're going to cancel each other out. Then look at what's left. Is the amount that's left the same on both sides or different? If the amount that's left on both sides, when the x's cancel each other out, if the amount is left on both sides is the same, then you're going to get infinite solutions. But if the amount that's left on both sides after the x's cancel each other out, if that amount is different, you're going to get no solutions. So let's go ahead and do some problems, and let's use that knowledge to do it. The first problem says complete the equation below to create an equation with infinitely many solutions. So we want something like this. We want the x's on both sides to cancel each other out, and we want what's left after that to be exactly the same as each other. So let's look at the equation they gave us. They started us off with 7x minus 8. So let's go ahead and write that down, 7x minus 8. That's what's on the left side. Okay, so 7x minus 8. And that has to be equal to, on the right side, 8, it's positive 8, plus something times x, minus something, and then plus 3x. So let's think about that for a minute. If I want infinitely many solutions, I need the x's on the left side of the equal sign to cancel out with the x's on the right. Well, how many x's are on the left side? I have 7 x's. That means I need to have 7 x's on the right. Well, how many x's do I already have? I have 3 x's right here. I need 7 x's, so that means the number of x's I need to make sure that we add on is 4 x's, because I want it to be 4x plus 3x, so that the x's on the right is 7x, and that cancels out the 7 x's on the left side. So I plug in a 4 into the first blank spot in this problem. But I'm not done yet, because I need what's left to also be exactly the same. On the left side, I have minus 8 after the 7x. So I need negative 8 to be over here. Well, what's over here so far? Positive 8. What do I need to subtract to make positive 8 and the number I'm subtracting equal to negative 8? And the answer is 16. That's what I need to subtract there. 8 minus 16 would be negative 8. So if I filled in those two numbers, this would be the equation. 7x minus 8 equals positive 8 plus 4x minus 16 plus 3x. If I were to solve this equation, I might say 7x minus 8 equals, and then I could combine my positive 4x with my positive 3x to make positive 7x. And then I could say 8 minus 16, I'm collecting those terms together now. 8 minus 16 is negative 8, so I write minus 8. And now what's on the left side is exactly as the same as what's on the right side. These 7x's cancel each other out. Whatever I plug in for x, this 7x is going to be the same as this 7x. And what's left besides that is negative 8 on both sides. So no matter what I plug in for x, these two will be equal. So I go to my field up here and I say, all right, I want 4x and minus 16. Now it says minus right there, so I'm just going to type in 16. If this was a plus symbol, I would have to put negative 16 in there. But make sure you're paying attention to your symbols. Let's do another question. Complete the equation below to create an equation with infinitely many solutions. So this is just like the last one. We want both sides of the equation to be exactly the same so that there are infinitely many solutions. Because when both sides of the equation are exactly the same, you can plug in any number for x and they'll stay the same. So let's go ahead and do it. I've got 4 times 5x plus 3 in parentheses. So 4 times the sum of 5x and 3 minus 9x equals 11x plus something. So let's go ahead and simplify the left side to figure out what we need to put over here. 4 times 5x, if I'm distributing this, is 20x. 4 times positive 3 is positive 12 minus 9x equals 11x plus something. Then we have 20x minus 9x. I can combine those two things together. Those are both numbers of x's. 20x's minus 9x's is 11x's. So 11x, I have plus 12 equals 11x plus something. Well, the whole question is asking us what goes here to make this have infinitely many solutions. And for it to have infinitely many solutions, the two sides need to be identical to each other. So we've already got the 11x and the 11x. The left side says plus 12. So the right side must also say plus 12. And that is this answer right here. All right. Michael hires a cab that charges a fare of 50 cents per mile plus an initial charge of $2. Jason hires a cab that charges a fare of 50 cents per mile plus an initial charge of $3.50. At how many miles will the fares paid by Michael and Jason become equal? This is asking us to set up a problem, but it shouldn't make any sense right off the bat. Don't they pay the same number of cents per mile? Yeah, they both pay 50 cents per mile. But Michael's initial charge was $2 and Jason's initial charge was $3. But since they both get charged the same amount per mile, is there any point they're going to have the same cost? It stands to reason that Jason's cost is always going to be an extra $1.50 more than Michael because it started $1.50 more and they kept growing at the same amount. So just common sense would say that these two fares were never going to be equal. So I'm going to go ahead and click that. But let's write the equation that it would want us to write if we were doing this problem with equations. Here's the equation that you would write. You would want to say that 50 cents per mile, and we'll say x equals the miles. At 50 cents per mile, so 0.50 times x, plus the $2, so $2, 2.00, that's 50 cents per mile plus $2. We want that to be equal to the other fare, which was 50 cents per mile, plus $1.50. So let's go ahead and write that. Equals 0.50x plus 1.50. So there is our new equation. I hate all the extra decimals. You don't need them. I know it looks like money, but you don't need all the extra decimals. So I'm going to go ahead and write 0.5x plus 2 equals 0.5x plus 1.5. What do you see? And I forgot to write my x. What do you see on both sides of this? I see a 0.5x that's going to cancel each other out. And then on the right side, it says 1.5. And on the left side, it says 2. So there's no way that these are ever going to be equal. So there are no solutions to this problem. The number of x's on both sides cancels out. And what's remaining is not equal to each other. So they will never be equal. All right, consider the expression below. 12x minus 6x plus 5 plus 4x. So this is an expression. That's something you might find on one side of an equation. If the expression were set equal to 10x plus 5, then there would be how many solutions? 0, infinite solutions, or 1. And then you're going to get asked the same question for if it was set equal to 10x plus 7, and the same question if it was equal to negative 10x plus 5. So let's go ahead and simplify that expression and see what it looks like. If I simplify that expression, here's what it looks like. 12x minus 6x plus 5 plus 4x. Well, 12x minus 6x is 6x, and 6x plus 4x is 10x. So this equation simplifies to 10x plus 5. Well, you notice right away that this is what it says right here. So our first option would be 10x plus 5 equals 10x plus 5. Those are identical to each other. The x's cancel each other out, and what's left is the same. So no matter what we plug in for x, those two are going to be the same. The next one says, what if 10x plus 5 was equal to 10x plus 7? Well, in this case, there's absolutely nothing we could plug in for x that would make them the same, because the 10x's over here cancel out the 10x's over here, and then what's left is 5 and 7, and those won't be the same no matter what we do. So this is 0 solutions. This is impossible. But then the last one says negative 10x plus 5, and that we will find a solution for, because our original expression simplifies to positive 10x plus 5, and the expression it's asking about in the third part of this problem is negative 10x plus 5. Positive 10x won't cancel out with negative 10x on the other side of the equal sign. For you to get infinite solutions or no solutions, it has to both be the same number and the same sign on both sides of the equation. So notice in the first two, it's positive 10x on both sides. They're going to cancel each other out, but these don't. So this will have one solution. I don't even actually have to find what that solution is. I know there's going to be one. Anytime the x's don't cancel each other out, there will be one solution, and that's it. So we're done with this problem. Now, that being said, I do want to solve this for you in case you want to know how to solve it. You add 10x to both sides, and that gives you 20x plus 5 on the left side equals just positive 5 on the right. Then you can subtract 5 from both sides, and that gives you 20x on the left equals 0 on the right. Now, 20 times what equals 0? Well, you divide by 20 on both sides, and x equals 0. That's a solution. A lot of kids will get confused because 0 is a funny number, but it is a number. It is a solution. If I plug in 0 into this equation, it will work. So 0 is the solution. Do not make the mistake of thinking that an equation with a solution of 0 is an equation that has no answers, because 0 is an answer. This equation might look funny because we have 10 times x plus 5 equals negative 10x plus 5. How could they be equal when they both say plus 5, but the first things are different? Well, you can multiply both of these by 0, and they'll both equal 0. And 0 plus 5 is equal to 0 plus 5. 0 is the only thing you can plug in that makes this work. If If you tried to plug in any other number, it would fail. But 0 works, so 0 is a solution. Okay, which statement represents the simplified form of the given equation and correctly describes the solution? So here we go. The left side is 9x minus 4, and that equals 2 times the sum of 8 and 4x plus 7. So let's go ahead and see what we get when we start working that equation. 9x minus 4 equals 2 times the sum of 8 and 4x, and then plus 7. Well, the left side is simplified. I can't put together 9 and x minus 4, so I'm just going to bring those down. But I can start simplifying the right side, and the first thing I'm going to do is distribute to get rid of these parentheses. 2 times 8 is 16, and 2 times 4x is 8x. So I write 16 plus 8x. And then I bring down my plus 7. Now I can simplify the right side a little further, so I'm going to write 9x minus 4 again, equals, and then 16 plus 7 is 23. So this is 8x plus 23. If I wanted to write 23 plus 8x, that would be the same thing. Now right away, are there the same number of x's on both sides here? No, on the left side we have 9x's, and on the right side we only have 8x's. So we are going to get one solution here. We will only get no solutions or infinite solutions when the x's on the same, when the x's on both sides match up and cancel each other out. But these won't, so we are going to get one solution. So right away, looking at my answers here, I know it's either going to be 19 or 27. It's either going to be B or D, because the first one says no real solution, and the last one says infinite real solutions. That's not the case here. What would the solution be? Let's finish solving. Subtract 8x from both sides. 9x minus 8x is 1x, so x, bring down the minus 4, equals, the 8x's are gone now, positive 23 left on the right side. So x minus 4 equals 23. And then you add 4 to both sides, and you get x equals 27. Okay, 27 minus 4 equals 23. So x is 27 is the right answer. X is 27, exactly one real solution. So which of the following equations has infinitely many real solutions? Which one of these does the number of x's on the left cancel out with the number of x's on the right, and what remains is still equal to each other? Well, let's look at A. I have to distribute to figure out what's on the left side. 6 times x, that's 6x. Is that the same as what's on the right? Yes. So the x's will cancel each other out. What else do we get? 6 times negative 8. 6 times negative 8 is negative 48. And that's what it would be right here, minus 48. So there they go. Both sides are exactly the same. Let's look at the other solutions, the other answers, the other options, and make sure we know why they don't work. On this one, B, 6x plus 1 equals 6x minus 1. That will not be infinite real solutions. That will be no solutions, because while the 6x's are going to cancel each other out, the left side is plus 1 and the right side is minus 1. Those don't match up, so there will be no solutions to this problem. For C, the 6x's on the left do not get canceled out by 6x's on the right. So we are going to get one solution to this problem. That would be one solution. The 6x's on the left and the 1x on the right don't cancel each other out. You'll end up getting 5x just on the left side if you started to solve this problem, and then 5x equals negative 2, and your answer would be negative 2/5. You don't need to know that. You just need to notice that the x's don't cancel each other out so that you will get one solution. And then last but not least, this looks a lot like the first one, but 6 times x is 6x, and that does cancel out with those 6x's, but on the left side it would be 6x times negative 8 is negative 48, so I would write 6x minus 48, but over here it says plus 48, so those do not match up. This one, B and D, would both be no solution. C is one real solution. A is infinite solutions. Okay, Aaron and Dan went shopping at their local store. Aaron bought shirts that cost $12 each and spent $18 on accessories. Dan bought the same number of shirts as Aaron for $16 each and spent $10 on accessories. If Aaron and Dan were billed the same amount by the store, how many shirts did each of them buy? So there's some number of shirts that they each bought. We don't know what it is, but we know that Aaron bought the same number of shirts as Dan. So we can write an equation based on that. We're going to go ahead and say that X is the number of shirts that each of them bought. So X is how many shirts Aaron bought, and it's also the number of shirts that Dan bought. Well, Aaron bought shirts that cost $12 each, and then she also spent $18 on accessories. So Aaron's expression would look like this for her total cost. $12 times the number of shirts, $12 per shirt, plus $18 in accessories. This is Aaron's total cost. $12 times the number of shirts she bought, plus 18. That has to be equal to Dan's expression because it says that Aaron and Dan were billed the same amount by the store. So Dan's expression, that Aaron's expression must be equal to, is $16 per shirt plus $10 in accessories. So we have $16 times the number of shirts plus $10 in accessories. This equation can now be solved, and I automatically know there is one real answer because the number of x's on both sides do not cancel each other out. So let's go ahead and solve. I can subtract 12x's from both sides. That gives me 18 equals 4x plus 10. Now I can subtract the 10 from both sides. 18 minus 10 is 8. So 8 equals the 4x. And last but not least, divide by 4 on both sides. 8 divided by 4 is 2, and that equals x. So each of them bought 2 shirts. Aaron bought 2 shirts at $12 a piece. That's $24, plus $18 in accessories. $24 plus $18 is $42. Dan bought $16 shirts, and he bought 2 of them. 16 times 2 is $32. So he spent $32 on shirts, plus $10 in accessories. That again comes out to $42. So they both spent $42 on 2 shirts. All right, which of the following best describes the solution to the equation below? Is there infinite solutions, one real solution, and it's 1, one real solution, and it's negative 3.5, or are there no solutions whatsoever? Let's go ahead and solve this equation. The left side says 7 plus 5x, and that must be equal to the right side, which is 1/2 times 14 plus 10x. Now, I notice that both of these are even numbers, which means when I distribute 1/2 to them, they're going to come out still as nice whole numbers. If they weren't, I might do some tricks to get rid of the fraction, but I'm not going to in this case. I'm just going to multiply by 1/2. Here we go. 7 plus 5x comes down, and that equals 1/2 times 14, which is 7. And then 1/2 times positive 10x is positive 5x. Half of 10 is 5, so plus 5x. Well, what do you know? They're exactly the same. The left side says 7 plus 5x. The right side says 7 plus 5x. So because these are exactly the same, the 5x's will cancel each other out, and we will have 7 on both sides remaining, which means there are infinite real solutions to this problem. Next one. Which of the following best describes the solution? Right here, they didn't even mess around or put parentheses or anything here. 8x plus 4 equals 8x plus 4. So no matter what you plug in for x, this 8x and that 8x are going to be worth the same. There's going to be 4 left on both sides. So anything works. There are infinite solutions to this problem. And number 10, the last one that we're going to do for now. Which of the following equations has no real solutions? So we are looking for the equation that has no solutions. That's impossible. Remember, for that to be true, the variables on each side have to be the same and cancel each other out. But what's left has to be different. So let's go ahead and look at the first one. 5x plus 4 equals 5x plus 11. Well, I shouldn't have read it that way, but 5 times x plus 4 equals 5 times x plus 11. What would those be? 5 times x is 5x. 5 times 4 is 20. So the left side for A, for answer A, if I was going to write that out and distribute, 5 times x plus 4 equals 5 times x plus 11. There are two ways to do this problem. I could just divide both sides by 5. It's a little shortcut that you guys may not know yet, so I'm going to hold off on that. But if I were to distribute, which you do know how to do, 5 times x is 5x, and 5 times 4 is 20, so plus 20. And that equals 5 times x is 5x, and 5 times 11 is 55, so plus 55. So right away, we have 5x's on the left and 5x's on the right that will cancel each other out, but we have different amounts besides that. So there's no way to make these two things equal to each other. So there are no solutions to this problem. B is exactly the same on both sides, so that's infinite solutions. C will also end up being exactly the same on both sides because 5 times x is 5x, and 5 times negative 4 would be negative 20. So this would also be infinite solutions. And this last one would be one solution because the x's on both sides don't cancel each other out. All right, I hope that is enough help. If you need anything else, please let me know. If you're having trouble with a very specific problem, let me know and I can check it out for you. Good luck out there.